but it is going to be two sample problems for series and parallel circuit calculations. So here's one example. I got this from the, I believe, physics classroom website. Very handy. And try to do this one. Look, identify it. This is a series circuit. You have your voltage total, you have your resistance. Figure out this. So pause this video and see if you can get the same answers as me. Maybe I'll make a mistake too. Okay, pause it right now. Okay, so to start this question, let's identify what we have here. Let's choose a nice color. Let's choose the blue color. And let's look at this. We have voltage total. So we know that VT is equal to 12 volts. Remember now, this is a series circuit. So if we know a series circuit, let's think. Voltage total, is that the same throughout or is that added? Well, think about my battery. If I were to connect them in series, they're all added together. Okay, so because they add up, so they're going to be added like this. So if voltage is added, then the current must be the same. So that's how I sort of, well, not adding. That's how I sort of remember it. And resistance is going to be same as voltage. So R1 plus R2, etc., 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 etc. So let's calculate this. Can we calculate the resistance total? Oh, yes, we can, because resistance total is the sum of all of them. So I'm going to take resistance total is equal to R1 plus R2 plus R3. So if I plug in these numbers, that's 11 plus 7 plus 20. That gives me 38 omega, and that's 38 ohms. So I got one thing done. So that's my RT, resistance total. Can I calculate my current total? Yeah, I can calculate this using Ohm's law. So VT is equal to IT times RT, and I have voltage is 12, I is, that's what we're trying to find. And my resistance total is 38. Remember, if your letters are side by side, that means they're multiplied together. Isolate I over IT, which is my I total. So that means I divide 38 just so then I leave I by itself. 12 divided by 38, I'm going to use my trusty handy calculator. So 12 divided by 38 gives me 0.32. Let's round off. So that's my current. So that's 0.32. So then what shortcut can I take right now? It's a series circuit. I know my current stays the same. So since I just calculated current, bonus, bam, I can just fill these in 3, 2, because the same current goes through all of the three resistance. Now to solve for individual ones, well, I think now you're getting the point because I use Ohm's law again. My voltage here is, I use, that's what I'm trying to find. I'm not using anything. I'm going to try to solve for voltage. And I have the same current, so 0.32 amps, multiplied by resistance 1, which is 11 ohms. And the answer here is 0.32 times 11, 3.52. So that's 3.52 voltage, just like that. So 3.52. And I'm sure you get the hang of the next one. Voltage 2 is the same thing, IR. But instead of using the 11, I'm going to use the second resistance, which is 7. So times 7. So that's going to be 0.32 times 7, which is 2.24 voltage. So that's 2.24. And the last one, I'm sure you know what's going on. So I'm just going to quickly go through this. 20's from here. So 0.32 times 20. Look at that, 6.4. So look, initially when we looked at this, it looks like there's a lot of calculations, but remember, your first key thing is to recognize, is it series or parallel circuit? And the second thing you need to recognize is which one is going to be the same. Is it voltage that stays the same, or is it current that stays the same? If you don't know that, then this is going to be pretty tough. But as long as you know that, then all the calculations are pretty easy. So let's try the next one. Next one is a short little parallel circuit. So you can see it's parallel because there's two different paths with two different resistors. So based on that, you should be able to figure out all these things. I total, resistance total. If you don't know how to calculate the resistance, look back on my previous video on resistance. We can calculate the voltage 1, voltage 2, so we'll call this V1, this is V2, and then we can also calculate the I1 and I2. So pause this video and see if you can get the same answer as me. So pause it right now. Okay, so first thing, we can recognize that voltage is 12 volts. That's what we have. And remember, in a parallel circuit, so this is parallel circuit, sometimes, I have to write this out just to refresh my memory. And if I look at the series circuit, I know voltage is added, right? Boom. So then that means parallel is going to be the same. If one is adding, the other one's going to be the same. In series, I know that IT, the current, is going to be the same because voltage is added for series, and that means the current is the same. So this is the same. Wow, because this is the same, then everything goes, and now this is all added together. So that should be I1, I2, etc. And in the series, resistance total is going to be R1 plus R2, da-da-da. But then parallel is the little tricky one because it has the inverse fraction. So 1 over RT is equal to 1 over R1 plus 1 over R2, etc., etc., etc. So then, voltage, I have 12 volts. It works for parallel because they're the same. That means voltage for 1 is going to be 12, voltage for 2 is 12. Okay? Can we calculate, what's the next thing we can calculate? Well, we are given resistance, so we can calculate the RT. So remember, 1 over RT is equal to 1 over 12 plus 1 over 4. Well, you're just basically adding two fractions, so 1 over 12, what's the common denominator? It's 12, so I need to multiply that by 3. So that's going to be 4 over 12. And this is not the answer. This is the answer for 1 over RT. So in order to sort of get RT into the numerator, well, this has to go up, this has to go up. Basically, just finding the inverse or flipping it. So RT is equal to 12 over 4, which is just RT is equal to 3 ohms. There you go. So that's 3 ohms. And with that new clue, then we can solve for IT. So VT is equal to IT times RT, substitute, so 12 is equal to IT is what we're trying to find, and the total resistance is 3, remember they're multiplying to each other, divide by 3, isolate, so that's 4 amps is equal to I total. So that's my 4.0 amps, that's for my current. And then with that one, well, we can solve for I1 and I2. And I think you guys are getting a hang of this. So, I pressed the wrong button. V, 1 is equal to I, R, and these are all for the first one. So voltage 1 is 12, I1 is what we're trying to find. So I'm just going to get I, and resistance is 3. No, never mind. Getting ahead of myself. This should be 12 times I1, and I'm using resistance 1, so don't forget, I just made that mistake right now. First one, that's 12. Not 3, that's the total resistance, right? This is the total resistance, this is the first one. So then I1 is 12 divided by 12. This is 1.0 amps, a little bit laggy right now. And then the next one, let's finish this off before my computer crashes. R2, voltage is 12, is equal to I2, what we're trying to find. And R2, now this one is the second resistance, so that's by 4, divide by 4, divide by 4, I2 is 3.0 amps. My computer is totally lagging right now because I'm ripping the other video. But here's your answers. So make sure you try it out. It's really important for you to try it out and practice these. Once you get a couple of these, I'm sure you'll get the hang of it. So hopefully you got them all right. So see you later.